Here we are going to discuss addition and subtraction word problems with fractions. So the things that you saw in MAE 201 with addition and subtraction problems involving integers or whole numbers, you can apply some of those same things to story problems with fractions. So the same types of problems that you saw, add to, take from, comparison, combine, missing addend, all those things that you did in MAE 201 and at the lower elementary levels, you can basically adapt a lot of those to make them work for fractions. It doesn't always work, but it often works. So if you have to write a story problem for fractions and you're struggling to come up with something, a good way that you could approach that is just try to go ahead and write a story problem for whole numbers and then see if it works to replace them with fractions. Sometimes it does and sometimes it doesn't. So like, for example, if I said that Sally had 3 apples and Damien had 5, how many do they have together, right? That's a simple combining problem that we would see in MAE 201. So Sally has some apples, Damien has some apples, and we would add those together. Would it work to replace those with fractions? So try it and see. So for example, if we said that Sally has 3/5 of an apple and Damien has 5/8 of an apple, how much do they have together? Could we do that? Would that work? And in this case, it would, right? So that's a good way if you do need to come up with story problems on the fly, that you could just kind of take something that you would have done with whole numbers and replace them with fractions. It doesn't always work. So for example, if I changed apples to toy cars, Sally had 3 toy cars, Damien had 5, how many do they have all together? That works perfectly well. But as soon as I replace them with fractions, who wants 2/3 of a toy car or 5/8 of a toy car, right? So it doesn't work for everything, but that's a good way that you could come up with some if you absolutely need to. And then if it doesn't work, you can always adjust. So if you did have that toy car problem and you realize, oh, well, nobody wants 2/3 of a toy car, then you change it to something that you wouldn't mind 2/3 of, like a candy bar or a cake or a pizza. So some ideas if you do need to come up with some story problems. Recipes are really great. I do a lot of cooking, so this is kind of my go-to because amounts of ingredients lend themselves really well to fractions. So you can really easily come up with some story problems, 1/8 of a teaspoon, 1/4 of a cup, 3/4 of a container of flour, or you can talk about servings, right? So I could have half a serving or something like that. You can even throw in some mixed numbers in there, right? We could have 2 3/4 cup of flour, or I could eat, 3.5 servings of something. Measures like weight, length, and distance, those also lend themselves really well to fractions. So my puppy weighs 44.5 pounds, or I jogged 3/4 of a mile. So you can put some fractions in really easily to make some story problems with that. And then don't forget about parts of groups. That's one that's often forgotten, but you can take houses, dolls, people, candy, put them into groups, and we can talk about, this group has this feature, and then all of a sudden we've got a fraction as long as we treat the group total as the whole, right? So we did an example earlier with houses and the fraction of them that had gray shutters. I could talk about, a jar full of candy and the fraction of them that are taffy, right? So there's lots of things you could do with that. We're going to do some examples here. This one says, on Monday morning, Sam had a full tank of gas. By the end of the day, he had used 2/5 of the tank of gas. What fraction of a tank of gas did Sam have left? So the first thing I want you to notice here before we solve this is just how it's asking the question. If you want a fraction as your answer, you need to ask it that way. So if you do write a story problem or come up with a story problem on the fly, you want to make sure that if you're expecting a fraction answer, you're asking for it. So we didn't say how much gas would Sam have left, and you'd want to be careful that you don't say it that way, because if we just asked how much gas is left in Sam's tank, you're going to get all kinds of answers. Students are going to answer in gallons, or they might just say over half a tank. So you're going to get a lot of variance in your answers. So we're asking what fraction, and then also notice that it doesn't just say what fraction of gas, it says what fraction of a tank. And by putting that in there, we're telling the student what the whole is. And that's important because you just say, what fraction of gas does Sam have left? Students might think you mean what fraction of a gallon. They might think that you mean, what fraction of what they had, right? So there's lots of different ways to ask this. So we want to specify what the whole is. So here we're saying what fraction of a tank. That means that a whole tank, right? One tank is our whole in this case. And then we could visualize this in any of the ways that we've visualized these typically. So fraction strips is kind of our go-to, but you can do any of the other things that we've done, pie charts and so on. One way that you could do this is you could actually draw your tank. I would say the best way to do that is just by using a rectangle. Now, whether you call that rectangle a fraction strip or if you just call it a rectangle, however you see to do that. But that would be a good way to do this. So I'm just going to say, hey, this rectangle right here, this is one whole tank. And I would put that. I would make sure my students know that that's what that represents. And then I could start playing with that. So I might even draw it again. I don't know that you'd have to, but just so you can kind of see the progression here, I would draw the whole tank first. And then I would start doing manipulations to it. So in this case, it said that he used 2/5 of a tank, and we're trying to figure out what fraction of that tank does he have left. So since it's 2/5, I would go ahead and split this into fifths. If you did it with strips, you would split it up vertically, but I think I'm going to do it horizontally. It's correct either way. I'm just kind of thinking of like a tank of gas, and the level of gas in that tank would go down, so gravity, so it would kind of go horizontally, if that makes sense. But you wouldn't have to do it that way. It doesn't really matter. One thing I would be careful of though is like if you were to actually draw, like I don't know what a tank of gas looks like because I don't know enough about automobiles, but I'm kind of thinking like, if I had like a container for gasoline, right? So like something like that, and maybe I was going to draw like a container and then I was going to take 2/5 of that. You want to be really careful there because this, like, how do I know exactly where a fifth is if it's got like these rounded edges and things like that? So you can make it look like the object, but really only if it's pretty rectangular, right? So if you really want to make it look like a tank, you could maybe make it a rectangle and then put like a spout or something on it. But you want to be careful that you can easily split it into equally sized pieces. And then we could cross out or shade or however you best like to do this. So I'm just going to say, well, I would have used the level of gas would have gone down, so I would have used what's at the top first, right? So I'm going to use the 2/5, and then I might pick a different color and shade what's left. So in this case, I can see that I would have 3/5 left. And my units here, if it's a story problem, it needs units. My units here would be 3/5 of a tank. So you could say of a tank, or if you just say 3/5 tank or tanks, that's probably fine. But we always want to include our units on our story problems. So let's look at another example. On this one, it says Jeremy ate 1/3 of a pizza and Kayla ate 1/4 of the same pizza. Now, this hasn't asked a question yet. Before we ask a question, I want to caution you here. So notice that on this problem, Jeremy and Kayla are eating from the same pizza. So you need to be really careful here about what fractions you use if you do that. Now, that would be different if, Jeremy's eating from one pizza and Kayla's eating from a different one. But if they're eating from the same one, then you have to make sure that your fractions don't go over, right? So like in this case, we're okay because they're 1/3 and 1/4. But imagine if I had changed this 1/4 to 3/4. Now we're saying Jeremy ate 1/3 of a pizza and Kayla ate 3/4 of the same pizza. That's not possible, right? Because if I put those together, that's more than one whole pizza. So you have to be careful about things like that if you're writing story problems or trying to solve story problems. So what could we ask at this point? We could ask all kinds of things. So we're looking at addition and subtraction. If I just wanted a simple addition with fractions problem, then I could ask what fraction of the pizza did they eat together, right? And so that would just be a simple, let me add 1/3 plus 1/4. I could also, if I wanted to do something a little bit more complicated, I could ask what fraction of the pizza is left. That's going to involve subtraction, but that's a little bit more involved because that's actually a combination problem. I would have to first add together what they ate, right? I'd have to add together the 1/3 and 1/4, and then I would have to subtract that from one whole, right? So that would be a combination of addition and subtraction. So something like this, 1/3 plus 1/4, and then take that answer and subtract it from the whole. So we could ask all kinds of things like that. What you don't want to ask is how many slices, right? So you don't want to ask something like how many are left because we didn't say anything about how this thing was sliced. So you're making assumptions at that point. So notice the way we ask it. We asked what fraction. So we're telling the student that's how we want our answer. And we said what fraction of the pizza, right? Or of a pizza would be appropriate. So by putting that in, we're saying the whole is one pizza. One pizza makes one whole. And we could draw this pretty easily. So if we wanted to draw this, I think we tend to think of pizzas as round because that's probably typical, but I think we've also all seen rectangular pizzas. And don't think that you have to stick with round. If a student's doing round, you want to try and stick with their method. But if it's harder for you to draw round objects, to use pies, draw that rectangular pizza, right? So if I did this as a round pizza, which I may not may not want to do if it's a little bit hard for me, but I'll try it. So this said Jeremy ate 1/3 of a pizza and Kayla ate 1/4 of the same pizza. So I'll start with Jeremy, and I'll just make Jeremy blue here just to kind of color code and make it a little easier. So in order to find Jeremy's section, I would need to split this pizza up into thirds. And yeah, that's a little difficult. So if you struggle with that, it might be easier to use a rectangle and then split it. And so he ate 1/3, so I might just go ahead and shade one of these thirds, right? Sorry, let me redo that. I accidentally kept erasing that, so I had to redraw it. And so since Jeremy ate 1/3, I'm just going to shade one of these thirds, or if you want to get creative and we could shade by drawing little pepperonis, or you could just shade it. It doesn't matter, but however you want to do that. So there's Jeremy's third. And then if Kayla ate a fourth, it's a little bit tough to do. So for Kayla's fourth, I would need to take the same pizza and split it into 4 equally sized pieces. So that's a little bit complicated with this pizza split into thirds. So that's why I'm trying to use different colors here. And then I might draw little mushrooms for Kayla, or you could just shade it if you don't want to do anything crazy artistic, or you could just shade. But you can see there's my little Kayla section is that 1/4. So then from here we could answer both of these questions if we want. So we could try and find what fraction of pizza did they eat, right? Meaning what did they eat together? And then we could also go ahead and find what fraction is left. And you could ask both questions. You just expect 2 separate answers. So if I think about whether I'm doing this with a picture or if I'm doing this just by adding 1/3 plus 1/4, the process here is to find a common denominator. And really finding a common denominator is the same thing as, taking those pieces and splitting them up into same size pieces. So if you've got your third, we know 1/3, if we multiply both the top and the bottom by 4, is actually equivalent to 4/12. And if we take 1/4 and multiply both the top and the bottom by 3, then we know that that is actually equivalent to 3/12. So Jeremy's part here, his 1/3, is actually 4/12. I'm gonna split this up into 4 equally sized pieces. I'm doing my best here. And then Kayla ate a fourth, which is really 3/12. So her section here that's shaded with mushrooms is actually 3 of those same size pieces. And we could actually take this whole thing and split it up, right? So if we just follow through each of those lines, you make sure I've got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my 12ths. Pretend I did it perfectly. And then I can see Jeremy's section is the little pepperonis, which is 4/12, and Kayla's section is the little mushrooms, which is 3 of the 12ths. And so if I count all that up, I can see that the total would be 7/12. And in terms of units, that would be 7/12 of a pizza, or you could just say pizzas would be fine. And then what fraction of a pizza is left, we could actually just come in and shade or count what's left here. So here's the 1, 2, 3, 4, 5 sections here. And you can see that's what this is actually showing, right? It's actually showing basically this is Kayla's, this is Jeremy's, and all of this is what's left. And we can see that there's 5/12 of a pizza left.